We want to see what is not about data, what is not data mining. So that is not the data mining, like the SQL. Some books say something like using the data mining using SQL. SQL can be used to find the information, some interesting hidden information as well, but just the SQL itself or any query processing language is not the data mining process. It may be just one of it, but it's not equivalent. Let's say that way. Also, data warehousing. Maybe some of you know that one. Have anybody heard about data warehousing? No. Okay, so we will talk about it a little bit so that you can get the idea what it is about, but it is not data mining. And so what's about the third one? This one, data warehousing, I knew it even though before I look at the data mining area, but the third one, the online analytical processing, this one, it looks, the names look weird, and what it's actually about is not quite from the name. It's like it's something else, but we will discuss about that later on as well. Expert system is on AI field, like try to recommend something based on the knowledge base and something like that. That is not data mining. Or simple statistical programs, like try to find mean, try to summarize all the data. Usually this kind of thing has to be done manually, so that is not quite data mining. If anybody of you want to go back to the previous slide, please tell me so, because sometimes I skip too fast or too slow. You can ask. And the motivation, roughly, why the data mining has been popular in the past decade. So first is we have too much data. Data is everywhere, and everybody loves to keep the data. I don't know why. I know they keep the data because they think that somehow the data should be useful, so they keep it, right? And so like the first bullet, that so much of the data, but after all the huge amount of data, they don't have any knowledge or the real information that they can get from those data. So actually, the old process is mainly using data analysts or statistician to analyze the data. But using the human, which is like data analysts here, is time consuming because we have to, the statisticians have to set the hypothesis and then try to look at the data to see if the hypothesis fit or not. And if not, they have to do it all over again. So it's like the key concept here is the old method is manual. So they try to find the automated way to do the same thing, or maybe same thing with some additional. And why now? We have a lot of computer. The first one is not. The first one is the way to acquire the data has gone to the fully automated process. Like if you have a satellite, somebody has a satellite and then try to look at the Earth, for example, and then the satellite just capture the image of part of the Earth every second, and 1 second it generates, I don't know, maybe 100 megabytes, and 1 hour there are so many gigabytes of data, and then they beam that all the time. So, and for example, NASA likes to keep all the information like that for further analysis. So it's not like the old time when we look at just the retail, when we buy the product, they keep the data like that. There are automated process of acquisition of the data. And the second, we obviously see that the computational power has gone exponentially. We have a lot of powerful PCs in terms of the number of PCs and also in terms of the performance of each individual PC, or not just PC, and then the massive parallel computer also it is more accessible to like the maybe universities in the past decade. Some organization can buy huge computer as well, or distributed systems that we can use group of PCs collectively to do one task. So the problem can be larger. We have cheap storage space. The hard disk is so cheap here, and the advance of the algorithm that it's like the algorithm is pretty mature. Even though some of them we can develop, we can improve, but some statistical algorithms are pretty mature now. Okay. So let's look at what is in one data mining algorithm. So basically they try to look data as an input and then try to find the model as the output. So they fit the data to a model, a specific model. The models can be predictive. Predictive means that the model will be used to predict something like classification, regression. All of this will be discussed later. So this one, I just want to list like the task or the basic thing about the data mining for today. Or time series analysis for the predictive model or prediction. The prediction and predictive is not the same thing. Predictive is, like I said, that it's used to predict some output. The model used to predict some output or try to classify. But prediction, in the definition of this book, it says like predict a value in the future. It's stressed on the future, like gathering the data to predict something on the future. The second model is descriptive. The descriptive is like the word. It tries to describe the model, the data, what is our data about, like why we have data like this. So the tasks include clustering. Maybe I'll expand it later, but not today. Summarization. That is, this one is like summarize all the important information about the data. Association rules or sequence discovery. That is the goal, and then how to apply, how to compare, maybe should be the better, how to compare the algorithms. So we have to have the preference or scoring, how to choose the best model, because there are so many models around, and then how to evaluate if this model is better than the other. And at the end, when we can define the model, we have to actually search the data, because it's like we want to extract any useful information from data. So at the end, we have to go through all the large amount of data and search it. The term model here, I'll try to stick with the book. So even though some point I don't